all the data from the terminal. The emails from the CSV will be input into Salesforce to find every employee, and then the expense data from the terminal will be added into the expense row. After this, the robot will create a Word document from a template with a status report for each person. The Word file will then be converted to PDF and sent as an email attachment. Finally, the robot will find the employee's position in SAP, and with all of the above data, will populate the Excel file used in the beginning. Now, let's start the robot and explain the process in more detail. The robot will start by opening the terminal, Salesforce, and SAP, and by logging into all three systems, preparing all the applications it will work with. It will browse the pages of the terminal and find the ID of the first employee. Then identify the same person in Salesforce based on their email address. The expenses are then added in Expense IT, the Word template filled in, converted to PDF, and sent as an email attachment. The robot then finds the position of the person in SAP, then moves on to the second person, looking for the ID in the terminal. After collecting the data, the robot sees that Salesforce does not display an account for Joan, so it creates one. After doing this, it fills the expenses on Joan's account, creates the Word document, converts it to PDF, and sends it as an email attachment. Then the robot moves on to the third person, and so on. Fast forwarding, we can see that all the data is completed in the Excel file for each person, and the emails for each person are sent with a PDF attachment.
Great. So a relatively quick and simple example there, but I mean, what we're seeing is a robot navigating with multiple systems simultaneously. Some of those are, Excel through to our core systems and Outlook, getting data from one system, putting it into another, going back and forth, copy pasting, moving data, sending emails, attaching files, etc. So a lot of sort of the basic things that we all can do. There's a script for it. The robot just follows the rules, and there we go. So we would consider that sort of more native and natural human emulation side to be sort of the core. I like to call it the RPA 101. And so if we move on from that
with multiple
so if we move on to that now, we can start to think about, well, what do we do with our business processes that require documents? So all well and good to be able to click and type and interact with digital elements on a screen, but what if that information is trapped inside of a document that may or may not even be a photograph of a document, so it's coming through as an image file as opposed to a native PDF and things like that. So to do that, UiPath has a capability called document understanding. It's effectively an intelligent document processing capability for those familiar with that term. And what we're doing is we're bringing together the sort of core RPA concepts that we saw before, i.e. where are we getting this document, where are we moving it, are we attaching it, are we downloading it, etc. So using RPA to be the arms and legs, using our document processing capability, which I'll show in a second, which can be used. There are options to do it with or without AI/machine learning. And we use all of those things in combination to achieve that document understanding processing capability. And the types of documents that we can handle, so there really isn't any restrictions on, what if a document, like I said earlier, is a scanned, like a scanned image or a photograph. What if it's a highly unstructured document? We've got solutions that can deal with all of those things. So whether it's a form XYZ that always looks and feels the same way, through to invoices, which are what we would call semi-structured, so they tend to contain the same information, but it may be variable as to where it sits, through to unstructured documents where all of the information may be on page one, or it might be split over 3 pages. Think CVs, contracts, things like that. And we have methods to deal with all of those. I'll skip this slide and come back to it if we have time. But I think a key, actually, sorry, I will just say the key point I wanted to make with this slide isn't to go through and say, look at all the great stuff we've done, but it's to say that the trend amongst all of our customers that have been successful with document understanding is going in not with an expectation or an objective that we will see 100% throughput of straight through processing of these documents with 100% accuracy. The nature of the technology is that sometimes we can't get to 100%, but even 60%, even 70% of automated processing of these documents can have a significant impact on saving time across the workforce and speeding up these processes. And for those that can be processed according to the rules, of course, we're going to see higher accuracies, quality, and auditability as a result. So it's not an all or nothing. It can be a sliding scale, and indeed, I see a lot of customers start with just almost like sample sizing. So if we're going to be talking about invoices, maybe we'll just start on processing from one provider that represents 40% of the volume. We could start simply like that and then expand the capability over time as we understand it better and can implement some of the reusability to help scale it quickly as well. So a quick demo of document understanding. So this first one will be around invoices. And this one doesn't have sound, so you have to listen to me talk. So in this one, we're going to be running in a demo mode. So in reality, this could be happening as an unattended solution on a different machine, but here we'll see Studio on the right-hand side. And we're going to be taking basically PDF attachments from an email and storing them into a document into a folder as the first part of this process. So the attachments are currently being extracted from the bottom left Outlook, and we can see just being saved into the top left folder now. So part one of that process completes, and we'll now start part two of the process to process the document. And again, in practice, this is running as a demo here, but these processes would of course be connected in a real example. So the first thing we're doing now is classifying the document. So we want to understand what it is that we're working with. So if we're expecting anything from an invoice to a CV to be coming through this inbox, the first thing we want to do is be able to classify what it is. So a robot can auto-classify according to either confidence levels or business rules, or it can send to a human to validate, hey, I think this is an invoice or something else. Can you please confirm? So once classified, this is where we can then run machine learning over the document to read it like a human would. And I'll just pause here for 2 seconds. And what we're seeing is the human, or at one version of the human interaction of this process. So on the right-hand side, we can see the document that we ingested. In the left-hand side, we can see all of the information that the robot has extracted. So we can see invoice number 39056. I've successfully extracted all of that information on the left-hand side here. And where that information is missing, e.g. this was a tax invoice with no PO number, then of course that has not been extracted. So we have two options here. I know it's a little bit difficult to see because of the quality, but we can see the robot's given a confidence score on each of these fields. 95% confident, that's the date. 96% confident, that's the supplier name. 88% confident that that's the invoice number. So we can start to build business rules around, if the robot is at or above a certain confidence level, then we may want to skip the human validation component. That's an option that we have, or we may decide to do that on a field by field basis, depending on the either the forms or the process use case that we're dealing with. So there's two options there: route it to a human for validation and or correction if anything was extracted incorrectly, or do straight through processing if either the confidence or other business rules have been met. So this is one of the interfaces of what the human interaction component would look like. Sorry, skip back to where we were. And we'll see here a table view as well. So if there is sort of multiple nested values in one or more tables, we can work with those two. So we've extracted those results, and the robot's now holding all of that data. The invoice data can now be populated into our ERP system, like SAP in this example. So we're now seeing the robot take all of that data that was extracted from the invoice and creating the invoice entry in our core systems. And that is processing of an invoice. So a second example we'll give now is a slightly different approach to document processing, and this is reviewing legal documents, specifically NDAs. And whereas previously we saw a machine learning approach to extracting data, this is using a more sort of structured natural language approach to I guess the semantics, if you will, within what's happening in that NDA file. So we'll see now that we've opened up through Salesforce, we have an NDA that's come back from a client. The robot will download itself a local copy of that. Opens the document to read it. We can see here already that there are some track changes in the standard NDA that's come back. So the robot's scanning for that. It's located at clause 3 that there's been changes made. It's now opening a new legal case to say please review section 3 of this NDA because it has changes. So that's sort of part 1 of what a robot can do. The second application of NDA is again reviewing for edits, but this time instead of creating a case, it's going to attempt some suggested changes according to policy. So same process, we go to Salesforce, download the NDA, and we can see that there are two edits there, and I'll just back that up a little bit because it was quite subtle. So we can see here that as it's come back in, the client's made changes of the default value from 50% to 10% and from 3 years to 1 year. Now, the robot is detecting those changes, and we will have defined a policy and thresholds for what changes we're willing to accept. And a robot can go through and then change what the customer had proposed to, I guess, back to what we would propose. So the robot's identified those 2 edits. Can place the updated file with our edits back into the similar case, or as before, upload a different case, upload the NDA and the comments again, as well as obviously the changes that it's made. And now this is providing advice back to the salesperson of what they should go back to the customer with. Now, again, of course, this is coming down to a lot of business rules. So, if there are straightforward business rules, we commonly see clients coming back requesting to change this clause or that, and we already know what our accepted threshold for change is, then we can program those rules for the robot to be able to follow, versus if something is too different and we just haven't seen it before, then the robot can go through and action what it can, and it can reroute any exceptions to the business rules to either to legal or to the sales reps or whoever we want. So that's just 2 examples of how we could process invoices through to NDAs, and a quick summary of what the technology is actually doing, I guess, behind the scenes. So when we receive these documents and they come in, if they're not already in a native digital state, i.e. native PDF or a Word document, and we can't get at the text directly, then the first thing we do is digitize. So we run that through an OCR engine to turn basically scanned or image text into digital text that we can work with. Once I've got that digital text, we can then put it through the classifier rules, and there, we have a no-code interface for business users to be able to tag or type sort of keywords and things like that correlate with that document to help the robot say, I know I'm looking at a CV, I know I'm looking at an invoice if I see a PO number, an invoice date, dollar values, a GST value, etc. I've got a high degree of confidence that what I'm looking at is an invoice, including if I see the word invoice in there, of course. Once I've classified the document, then we can extract the data that's in that, and then once we've extracted the data, as we saw in the previous example, we can process that into SAP or any of our other systems. And there's 2 extra steps here. I did say that we have the option to either route to a human or do straight through processing, and that option exists at both the classification and the extraction steps. And again, depending on the use case and the business rules, you could do one or the other or both of those pathways. And when we do route to a human for validation, and where the human makes any corrections, data was extracted incorrectly, robot classified something as an invoice when it should have been a receipt or something like that, then any human validation activity it takes that data, captures it back into a training set to then retrain the machine learning models to be more accurate in real time. So in effect, the more we're working with the robots, the longer the processes are running, the more documents we see, the more accurate and more reliable these models become over time. So that's the quick whirlwind tour of RPA and document understanding. There's a couple of other things after this before we head into questions. And I do see that the chat is blank, so please, if you have any questions, jump in now and you'll be the first one answered. So there is a couple of next steps, and there's no need to write down all these URLs. We'll send these after the session. But if you did want to learn more about document understanding specifically, we have our product pages, or there's a more in-depth sort of educational framework that we have. So quite a structured a combination of text and video-based learning with quizzes at the end and things like that to just get a better feel of our product. Of course, for those that want to jump straight into the technical deep end, you can go straight to the documentation. I'll provide a link to that. In addition to, if you are going to check out the Academy, we do offer free trials. So we can offer trials at a personal, individual level through our community tier, or we can offer an enterprise trial that can be registered through one of our sales executives. And I think they are 60-day trials with access to the platform. And of course, if there's any other questions after this session, you can contact either me directly or one of our directors of our technical consulting team, Tony Nudd. You can contact him directly as well. So Q&A. The floor is open. And I'm happy to take questions around both RPA and document understanding, but preferably document understanding capabilities given the agenda. I think that's what people are here to hear about, but happy to take questions on anything. What would be the success rate of data extraction on bank checks? So I would say quite high. I will say that because we would consider bank checks to be a semi-structured document, similar to invoices, albeit probably even better because there's less variability in banks, and therefore I think the number of different formats of checks that we would see versus invoices that might come through, from depending who we're working with, we've got thousands or tens of thousands of suppliers, and some of those suppliers may have very abnormal invoice formats versus bank checks, which are all going to be roughly very similar and from far fewer providers. So I think in terms of the structure, we'll see better accuracy. The thing that would impact the success rate of bank checks is going to be the accuracy of the, I suppose, of the handwriting. So where we had the digitization step, that's where we'll be taking the text that we see and turning it into digital text. So the success rate on handwriting, if I had to give a figure, on the accuracy of handwriting extraction, which is really going to be where the success of bank checks comes in, I'd say it could be as high as 80, 90%. But you may also want to embed some rules in there to make sure you're catching anything that may not be correct. And some good examples of that are if you know roughly the range of what a dollar value should be. So a crazy example would be where a robot's processing a bank check, but the value is $1 million. We can set a threshold limit to say if any bank check comes in over the value of $1,000 or $10,000, or depending on the use case, then we can bake in those rules to say don't process that one. Route it to a human because it's a business exception, and we want to be able to follow it through. So there are valid reasons to not want to push 100% as well. But if I had to give a finger in the air answer, I'd say probably about 70 or 80% on the handwriting accuracy, which would then lead to sort of your broader accuracy of that use case. Is it possible for document understanding to extract and identify signatures in documents? Yes. So and without going into too much detail, what sits behind all of this, we do have a product called AI Center, which is basically the machine learning powerhouse that's running and serving all the models. And there are multiple models that we offer. So And I'm not talking about needing to be a data scientist or a Python developer or anything like that to be able to create and use these models. We offer quite a wide range of out-of-the-box models that you can sort of just plug and play, or if you do want to build your own, they're as simple as sort of tagging, like a business user can literally click, say that's the invoice number, on some sample documents and train them that way. So it's a completely no-code environment. And we do have a couple of pre-trained models for we have one that's called object detection. So we can say run that model over our documents and look for signatures and then basically bound them and extract them. So we're sort of removing everything else off the page and we're taking effectively a screenshot or a snip of the signatures and we're extracting that. And the other thing we can do with signatures is say when we have two or more signatures, say we have a signature that's come through on a document, but we also have a signature on file for some customer, we can then actually run a comparison against those two signatures as well using another out-of-the-box machine learning model that will give you a similarity score. And we could use that as basically as a triage tool for fraud to say, we've found and extracted the signature on this form and we've compared it to the one on file and we've given it a 72% match or an 85% match. And you've got control over the threshold to say, if anything's under a X% match, then I want this person and this team to be made aware, and I want this application to be put on hold until a human can review anything like that. So there's quite a few things we can do with signatures. Yep. If we have 500 to 100 unique invoice templates, how would that work? So invoices. So the good answer with invoices is we've already pre-built and trained a out-of-the-box invoice model on quite a wide variety of invoices. We have a global one. We have an Australian one. We do have them for a couple of different countries as well because of countries that have, I guess, nuances in. In Australia, for example, GST on an invoice, obviously that might not be on every country. It might be VAT, might be something else. So we do have a global invoice model, and we do have localized invoice models, and they can be run on all invoices, regardless of how much variability you have in the templates, because we've predefined what we're looking for, and we've trained it on a big enough sample set that we see pretty good results. Now, if your invoices have highly unique values, they may need to be retrained on a couple of documents that are sort of specific to your use case and your business context. And again, what that looks like is taking an existing model, giving it a sample of let's say 10 or 20 invoices, and on each of those through the UiPath software interface, simply saying, I want to add an additional field I care about because I'm receiving invoices that also have a provider number on it or something like that that isn't standard, but specific to my business, and I also want to be able to extract that data. Then you just need to give it, say, 20 odd examples, upload 20 documents, and click. This is where the provider number is every time, and then hit the train button, and then the machine learning will say, okay, I've seen enough examples now. I can now start to attempt extracting this on my own, and the more we put through, the more accurate it gets over time. So short answer, yes, we have out-of-the-box pre-trained models, and they will work across quite a large variety of invoice templates. We've got customers that have over 10,000 suppliers using those models. But just do think about if there's any sort of hyper-specific things that might deviate from what a standard invoice might look like for you. Do we have a limit on the number of pages and sizes of documents that we can process? No. And we can even do document splitting and sub-classification. So if somebody's attached it's a good example, if you have a 10-page application form and that application requires supporting documentation, and that comes through with 10 pages, a photo of a driver's license and a photo of a passport, let's say, then the classification will take that document and it looks at every page and it says these first 10 pages are part of the application, but page 11 is a different document type and page 12 is a different document type. So you've got one file, but 3 identified document types within it. And then once we go to extraction, we can extract based on all 3 document types. So we can say, run the application model over the application, look for and extract what we want. But then over page 11, which was the driver's license, run the driver's license model. And then over page 12, run the passports model. And I use both of those examples because, again, both driver identification documents and passports are also models we have out of the box as well, pre-trained. The ML algorithm used in document understanding are standardized, or can they be modified if required? So they can be. So the algorithm itself, i.e. the code base that's actually building and training the models, that's not editable. So that's baked in as part of the UiPath software. But the ability to use that algorithm to either create new models on new document types that aren't anything we've just discussed. It might be maybe you want to do CVs and we don't have an out-of-the-box CV model. You can resumes and things like that. Then you could train from scratch using the underlying code base. But again, you're not required to interact with that. You're just interfacing with basically a user interface that says, give me 20 examples, and then on each of these examples, tell me the 5 fields you care about. And then on every sample document, you're simply clicking and saying, that's field 1, and there it is. That's field 2, and there it is. And you do that for all 20 documents, and then you hit train, and it will produce you a model that you can then run over any of your workflows or any of your documents. So it's a yes and no answer. So the ML algorithm, the underlying code that's used to generate the algorithms is standardized, and you can't modify that, but it's built in such a way that you can build theoretically an unlimited amount of unique models based on the documents that you're dealing with, and those are absolutely customizable, including our out-of-the-box models that can be retrained. So the Invoice one, for example, or any of them, you can take it and then retrain it on your specific documents in the hope, I think, that you would get better results as it's more contextualized to the nature of the suppliers that are sending you those invoices. Hope that answers the question. So that is the bottom of the list of questions. Is there anything else? I'll just give it a minute or two to see if anything else comes to mind. Just think about what else I can share. So I didn't, not everything, sorry, I'll come back to that thought in a second. If I have 10 different invoice templates and I trained the ML model on it, if I receive a new supplier template not trained with the same fields, so you would not have to retrain it, no. So, and that's the reason why our out-of-the-box invoice model works. So if ours has been trained on a lot more than 10 different invoice formats, but let's say you were to train your own in-house model from scratch and you trained it on 10 different templates / formats from 10 different suppliers, and then you had supplier 11 provide you with an invoice, it would be able to extract from that. It would be able to extract the data. Where we see a degradation in the accuracy of that extraction is if that new supplier invoice looks nothing like an invoice. And by that, I mean, typically we would see all of the right keywords at the top. We'll see the supplier name and the invoice numbers at the top of a document. Invoice numbers usually preceded with like a hashtag, and it's however many letters. Digits, I should say, and we'll usually see a table in the middle and some dollar values at the bottom, and a GST in there. Use Australian examples somewhere down the bottom. So roughly everything's in that sort of format, even if things move. So let's say you've trained all of your documents, you've trained a model on that, and then supplier number 11 comes in, and they've got, up the top in the middle, it says $10,000 total invoice amount. And the itemized table is on a separate, it's on page 2, and it's got sort of no headers or anything like that. And the supplier address is right down the bottom left, and the invoice number is the letter F, right? That's going to look very different to anything else that the machine learning model has seen, and therefore it's probably not, well, I would say it's definitely not going to be as accurate when it attempts to identify where the relevant information is and extract it. And the reason is it's because it's unlike anything it's seen before, and therefore we'll see at both classification and extraction. If it's the first time it's seen something that's radically different, it will still have a go, but its chances of being incorrect or not being able to find the value increase. So that's why it's good if you are training models, and it does, and that everything I've just said is true for invoices as it is for any other semi-structured or unstructured document type. It's good if you can get a variety of different formats. So don't get a sample size of 20 and train it all on the thing that looks the best. Try to also train it on the ones that come through that are nasty, that that might have handwriting, that might have those anomalies. And a good rule of thumb would be the ones that your team struggles with. Get those in there, because if you're training it on that, then it should be able to handle more as it comes through. And the other thing I was going to mention earlier as well, that we've spoken a lot about the sort of the machine learning model methods of extraction, where we're dealing with structured forms, i.e., the application form X, where we know the first name field or the first name is always going to be written in the first name field that's located here, and every time that this document is submitted, it looks it will always be in roughly that area on the form, give or take a little bit for skewing and things like that for when scanned images come through, but we know where it's going to be. So for those type forms, those types of documents that are form based, we don't need to have huge sample sizes of like 20 documents or so, 50 documents, or be concerned about machine learning accuracy, because what we if we know where the field is going to be, we don't need to call upon machine learning accuracy to go and fetch it. We can just say, once we've classified this as a form X, where the first name field is, just go and grab it. And the way we do that is by giving it one sample document, going through every single field, and basically snipping, like click and drag, to say highlight the first name field, and then add it to the list of this is the first name. And you would do that for every single form. I work a lot with government, so we've actually built that on 8 different forms, and some of those forms have over 200 fields, and they're getting millions of applications, or actually I think it's close to just over 1 million applications a year on average, for the use case that we're working with, and they only needed one example of every form type, and one business user went through and did all the tagging. I think it took them like 2 days maybe, because they were very thorough, but it can be done in a couple of hours if you don't have that many documents and 200 fields per document type, per form type that you're processing. They can be built quite quickly and quite reliable where we are talking about structured data. So just to call that out as well, that if it's forms and when we are dealing with structured documents, all of this discussion that we're having around 80% accuracy and extraction and things like that sort of goes out the window, because we're no longer using machine learning to try and find the field. We know exactly where it is, so we see very, very high levels of accuracy on those. AI Center is a prerequisite for document understanding. So when you would, I'll touch on maybe a little bit technically, the architecture of it. So AI Center, and if we're talking about cloud, I'll talk about cloud first, and then I'll talk about any on-premise deployment. But AI Center is the product that serves the models. So what the robots are doing, they're downloading the attachment, grabbing the document, and the robots aren't processing the document themselves, because that would require every machine that a robot runs on to have specs sufficient to run a machine learning model. What they're doing is that they're passing it to the server, which AI Center is sitting on, which is, if we're in SaaS, then this is all very seamless. You don't have to really worry about deploying AI Center. It just exists in the cloud. The robot will send it to AI Center, and AI Center is where there's all the higher amounts of CPU or GPU that are allocated to quickly power through those models and provide a quick response back to the robot in the form of effectively the payload. So robot gives AI Center the document, AI Center gives the robot the 10 extracted fields, for example. So AI Center is a prerequisite, but if we're talking about SaaS, there's really no extra effort. If we are talking about an on-premise deployment, whether that's a Windows or a Linux-based deployment, then we do have to deploy a single AI Center server, and the more information, if you want to get into the weeds about this, is you can find that through the documentation link that I'll send through. It's the same concept. You would deploy a single server, and the robots would be running on, say, Windows machines, sending a document to that server. Server provides a response. So if it's on premise, yes, you have to deploy the server and install AI Center. If it's SaaS, then it's just it comes with the cloud, and there's no additional license costs or anything like that for AI Center. Only for the sort of consumption-based document processing. I hope that answers the question. All right, I think this was set for 45 minutes, and we're almost at the end of that. So I'll just give maybe one more minute if there's any other questions. Otherwise, we might leave it there. And just to reiterate, very happy for anybody that, if you have any questions that come to mind after we end the call, or you wake up at 2 a.m. and you think, should have asked that, curious about whether we can or can't do something, or you want to sort of pursue a discussion with any of our sort of SMEs or myself, very happy to jump on calls or just be sent an email at any time to answer any questions you have. So don't hesitate to reach out. And no more questions, so I think we might leave it there. So I'll expect an email to come from me probably in the next, if not this afternoon, then tomorrow morning, with some of those links and where to go from here. So thank you for everyone's time, and hope to see you in some of the next sessions we have coming up later in the month. Cheers.